So, hello everyone, and welcome to today's session of Ask AuxEn Anything. And as you know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any RCC steel design concept or any project that they are doing or construction or site related issues. So, this is the 69th such episode that we are conducting. And let us begin by taking the queries that have been asked for this week. So, let me first take the queries that have been asked on the Google form, and then we will look at the queries that have been put on the email, and then we will take it from the live audience. So, I hope my voice is audible. Okay. So, the first query is Mr. Abhishek is asking, Engineer Abhishek from Delhi. He's a working professional. He's asking how to design a 2D frame jack porter in Stat Pro. So, yeah. So he's asking how to design a 2D frame jack portal in Stat Pro. I'm not sure what jack portal means. Anyone in the audience who knows what is the meaning of a jack portal? Let me look for any email images that he has sent. No. So not sure about this. Not sure about the meaning of jack portal. Uh, Not known. What is this? So if you have some additional images, you are requested to share. In the meantime, let us move to the next query. So next query has been asked by engineer Ketan Mahajan. He is a working professional, and he's saying, I want to know the design process of floating structures. I want to I want to know the design procedure of floating structures. I want to design the cage that binds these floating pontoons. Please tell me the design procedure, load, support conditions, etc. I have shared some images on WhatsApp. So let me see the images that he has shared. So this is the image that he has put, and he had shared some images earlier also. So these are his. This is the cage. Perhaps this is the cage that binds the floating pontoons together. You see, this is the steel frame that is holding the pontoon together, and he wants to design this. So please tell me the design procedure. So again, I have never done such kind of a thing before, as I had informed you earlier also on WhatsApp that I have not done this kind of a thing before. So I'm not sure how to do this kind of a work. But then if it is floating, I don't know. Any ideas from the audience? Any idea from the audience over here? Because I have never done such kind of a work, so I don't have, I'm not getting ideas how to do it. So this is supposed to be floating, and if it is floating, I don't know how to, what sort of forces to be applied on this. So I do not know. Okay. Maybe there must be some specification sheet for these pontoons. So maybe that tells you that what sort of, because maybe these pontoons try to shift away from each other, and then these things are holding it together. So maybe in the specification manual there might be some information that you might get, but otherwise, as of now, no idea comes to my mind. I do not know. If anyone in the live audience has any idea, they are requested to suggest. Then next question is from engineer Ajinkya Dinapurkar. He is from Pune and he is a working professional. So his query is, there is one leg of shear wall earlier designed. Based on the design, dowels are provided in raft, but after revision, reinforcement got increased in that leg. So we suggested to increase the steel by rebarring. As per IS 16700, we suggested to design the embedment for 1.25 FY strength, but the post installation agency says that if we design for this, concrete breakout failure will happen before bars reach up to 1.25 FY. They suggest to design as per actual force in that leg, but the shear wall as whole is not in tension but in compression. Therefore, there will not be any tension force as such to design it for post installation. I would like to hear your thoughts and solution if you have. No, which clause in 16700 says that? Which is the clause that says this? Which clause in 16700 says it? Let me just see. And that 16700 clause, if it is telling you, it's not about the it is not about net tension. My thought over it is that it is regarding the overstrength that your wall may generate. And when you look at the boundary elements, you need to understand that those boundary elements may generate the overstrength because they are sort of resisting the bending moments under tension and compression. So you need to see why the overstrength 1.25 fy is given to you. Okay. Let me just look for the clause in the code which says this. If you are attending the session and if you are in the audience, just tell me the clause that says this 1.25 fy. So I'm just going through the 16700 quickly. Structural wall. Yeah, at locations where yielding of longitudinal reinforcement is likely to occur. See, this is the provision. This is that provision. At locations where yielding of longitudinal reinforcement is likely to occur as a result of lateral displacement, development length of longitudinal reinforcement shall be 1.25 times the value calculated for the bar yielded in tension, that is at a stress level of Fy. So where does the longitudinal yielding occur in a structural wall? So if your wall is subjected to lateral load, I have drawn elevational view. and maybe this is in tension, this is in compression. So then at locations of tension, if your uh, wall is subjected to longitudinal yielding, then you have to provide 1.25 fy. Now how to check that? So perhaps you could look for the, based on the reinforcement provided, one thing you can do is that you look for the reinforcement that has been provided by you. On that regards, you try to calculate the mpr, okay, and see if the moment that is being resisted by wall, let's say mu, no, calculate mn, not mpr, calculate mn, the strength, nominal strength of this cross section, try to calculate that. And if your mu, or the moment that is being taken by the wall under the effect of lateral load, if your mu is going beyond mn, then you can say that wall is undergoing yielding. And if that is the case, then you need to provide 1.25 fy, not otherwise. Okay, so otherwise it won't be needed for you to provide 1.25 fy. So you need to check what is the moment being resisted by the wall and see if it is going beyond mn nominal moment strength or not. Okay, and then you need to decide. So let's say if it is going, then technically as per the code 1.25 fy development length is needed. Now you say that you're not able to provide 1.25 fy, so perhaps uh, they are saying that concrete breakout failure will happen. So just try to see that, let's say this is your raft. I'm drawing a sectional view. This is your raft, and this is, let's say, the raft thickness, total depth of raft. And from here you were supposed to start your wall. This is the sectional view I'm drawing. So look for this, that can you just make a small little pedestal over here? Can you cast one extra pedestal over here? And what that will help you in doing is that now you can take the bars, anchor it inside, okay, and over here in the pedestal you could provide some secondary reinforcement to control the breakout, secondary reinforcement to control the concrete breakout. So this can be one of the options that you can explore. Suppose you need to provide 1.25 fy, that making a small pedestal and then trying to look for the, then try to see if secondary reinforcement like this can be provided to avoid concrete breakout. Okay, so these are my thoughts on your query. Moving on to next question. Okay, so these were the questions asked on the Google form. Now we have question from so let's take the question from live audience. Engineer Ravi Chandra is asking how to design the grade slab with and without uplift. Kindly explain small calculation. So why do we need to have up? I mean, it's very rare to see uplift in grade slabs. Why are you having uplift in grade slabs? If uplift is there in grade slab, do not design it like a grade slab. Because what will happen if you have uplift in grade slab, there will be water seepage through the grade slab into your main structure. So if this is your plinth beam, I'm drawing a sectional view, and this is your grade slab. Generally, we design the grade slab as a floating slab. Floating slab means it is just resting on the grade below. Okay, it is just resting on the grade below. So you are saying there is an uplift case. So if there is an uplift case, the water will percolate through the sides. You cannot resist it. And I will suggest, if there is an uplift, do not design it like a grade slab. Or if the water level is so high that the water level, groundwater, is just near to the grade slab level, that means it is almost, the water table is almost at the plinth level itself, then suggestion is to not design it as a grade slab and just give a suspended slab, give a regular suspended slab. Suspended means the normal slab that we give connected to beams and not resting on ground and uh, designed for your normal movements, etc. For other grade slabs or for your general grade slabs, you design usually it as a pay, just like you do as a rigid pavement. If you have seen the designs that we follow for rigid pavement, that is the process followed for normal grade slabs, where we use the Westergaard's equation. We use the Westergaard's equation for design of grade slabs usually. So references can be had. Just hold on, I'll be back. Yeah, so references can be made for grade slabs. You could refer these documents. So one is this PCA handbook. No, one is this British document TR34. One is this British document TR34, which is a comprehensive guide on grade slabs. It's a British document, but the Indian standards also follow the same procedure. One of the other documents is uh, industrial flooring design. Although it's for industrial flooring, the same principles can be applied for grade slabs also. Industrial flooring design as per uh, design TC09. Okay, Technical Committee 09. This is a handbook that has been prepared by Indian Concrete Institute. So this is another document that you can refer to. Okay, and although it's for industrial flooring, but the same sort of approach can be followed for grade slabs also. So these two documents you can refer to. Otherwise, you can go to any book which covers rigid pavement designs, maybe any transportation engineering book you can refer and look for calculations. Mr. Rohit Patel is asking, hello sir, for planted columns, do we need to release the movements? It depends on what sort of connection you are going to make. Generally, because the connection is cast in situ between the planted column and the beam, and because the reinforcement is also developed, moment release is not a very good idea of doing it. But I have read some documentation books where they try to make some reinforcement arrangement, which is like pin sort of an arrangement. They try to provide some pin in the reinforcement itself. So maybe over there they provide moment releases, but generally speaking, moment release will not be there in the actual sort of structure because of cast in situ columns and because of the development length that you are providing in the reinforcement. Okay, that is my opinion on the thing. If you want to release the movement, then you have to be very careful how you are providing the reinforcement detailing at the ends of the planted column. Mr. Mohammad Sharif is asking how to design transfer slab. Any literature is there? Right now, I'm not aware of any literature. Usually, transfer slabs are to be designed just like you do your raft. It's just like a raft, not supported on not supported on soil, but supported by other column elements. So technically, it's just like a raft, and the principles of uh, flat slabs and the principles of raft are involved in transfer slab design. Any literature right now, I'm not aware of any books or documents that cover this topic well. Yes. Any other question? Any other query from the audience? Yes, please. Mr. Rohit Patel is saying for planted column there is no restraint. What if we do not release the movement, and what if we don't give restraint? No, you are not supposed to give restraint. Planted column is resting on the beam. So the assumption is that it is rigidly connected to the beam. And that's what I was saying, that if it is rigidly connected, and let's say you have provided cast in situ connection between the planted column and the uh, supporting beam or supporting slab, whatever you have, and if the reinforcements are also developed, then the assumption of rigid connectivity between planted column and beam holds true, and therefore no releases shall be made. If you are making any release, do not release. I mean, even if you are, let's say, making release, it will be a you need to allow the no translational restraint in the vertical direction should be provided, because the gravity load will be transferred to the planted sorry gravity load will be transferred to the beam or slab below. So if even if you are sort of trying to release something, some degree of freedom, if you are trying to release, you need to ensure that lateral restraint in the vertical direction is not provided. Okay. Mr. Ravichandra is asking, in IS 16700 code there is a word combined peak acceleration. Let me just open 16700. Just a minute. I'm just trying to open the 16700 in the background. Which clause number do you remember? Do you remember the clause number? I have just opened the 16700 in the background. If you remember the clause number, kindly inform. Okay. Any other query? Any other query anyone has? Clause 6.2.3. 6.2.3. Oh, so the 6.2.3 clause says, from serviceability considerations under standard wind load with return weight the maximum structural peak combined horizontal acceleration A max in the building for along and across wind actions at any floor level shall not exceed this. Combined horizontal acceleration. So Mr. Ravichandra is asking is what is this combined, what does this combine mean? Does it mean that we have to combine the across and along? It's very highly unlikely that you will be required to combine the across and along things together. Let me see in the notation if anything is given. No, they have not given any notations also. Uh, Mr. Ravichandra is saying, as I understand, this combined is nothing but along plus across. No, I would not say so. No, it won't be. Because, see, across and along are two different actions due to wind, and those effects are not combined together, they are checked separately. So we have separate requirements and separate checks given for looking at the combined, sorry, for looking at the across response and along response. It should not be added together. It makes no sense to add the across and along together. So I'm just looking at the 875 part 3. And because even if you see wind tunnel testing studies, even if you see the wind tunnel testing studies, they also do not combine across and along like this. They give separate calculations for the different responses. Okay. So let me just have a look at the 875 part 3, where they have given the gust factor calculations, dynamic wind calculations. I'm just trying to see if they have given any such terminology is used over there. So right now I'm not sure. Right now I'm not sure what this combined word means. So if anyone has any more idea about it, they are requested to kindly inform. Okay, Mr. Rocky is saying A max equal to SRSS of along plus across. Is it sure? Yeah, because in tall building course also we have checked it separately. That's what. We checked it separately. We did not combine it. Rocky is saying that you're supposed to do the SRSS uh, of the. So he's saying A max equal to under root A of along square plus A of across. I'm not sure. I'm not sure right now. We need more information. I am unable to make any comment as of now. Rocky is saying ASC empirical equation. Okay, I'll also check and maybe I'll try to study more. We need, as per as per his information. We will try to refer to ASC 7 and check it for ourselves. Okay, thank you, Rocky. All right. Anything else? Any other question? Okay, then. So I think that's all for this week. We have taken all the queries from the live audience, and we have also taken the queries that have been put in the Google form, and there were no queries asked on the email. So that's all what we have for this week. And as you know, that every week once we meet during the weekend, so you can continue providing the questions in the same Google form. And once every week when we meet, we will take up your questions. Mr. Ravichandra is asking, kindly inform or tell what is the mass unsymmetry in 16700. Mass unsymmetry. What is the clause number? 7.4. Movement. It is not movement, it is movement, building movement. Mass asymmetry means if your masses are mass asymmetry means if your masses at each level is varying, and generally the variation is given to be, if you were to refer to uh, IS 1893 horizontal irregularity, they say that mass asymmetry is when, or mass irregularity is when your masses at different story levels are different, and I think the variation is 1.3 times masses. So if your masses are varying at each floor level by more than 30%, they call it as a mass irregularity. And now this asymmetry may be in the plan view, that uh, let's say in this plan view this portion is heavily, I mean this portion is lightly loaded, this portion is heavily loaded in the same plan view. This can also be one type of mass asymmetry, or the masses are very different at each story level. That can also be a type of asymmetry. Now generally this 30%, if I remember correctly, this is a mass irregularity, and it is termed as one of the irregularities in the structure. I think it's not a horizontal, it's a vertical irregularity that is there. Okay, so that can be one of the irregularities. And asymmetry of mass may mean that there are differences in the same story level. There are one, let's say one portion of the floor area is very heavily loaded, one portion is lightly loaded. That also may be called as a mass asymmetry. In code saying analysis shall be carried out in horizontal and vertical, what analysis shall we carry out? So where it is given? Where are you reading this clause from? Please inform the clause number. Same paragraph 7.4. Oh, analysis shall be carried out for both vertical and horizontal long-term building movement. So for vertical, that is the creep shrinkage calculations that you need to carry out. Okay, for vertical deflections, you need to carry out the creep shrinkage deflection calculations. For horizontal, I think you need to just carry out your lateral, you need to calculate the lateral drifts, etc., and see if it is within the permissible limits. So You calculate the lateral deflections, lateral drifts, and you do that sort of calculation. So I think they are talking about that analysis. Okay. Okay. So I was saying that throughout the week you could ask your queries in this Google form, and once every week when we meet, we will take up your queries. So the link for the Google form remains the same, and this is the link that I am providing. Okay. So you could just keep putting your queries over here, and then when we meet, we will take up your queries. If you want to connect with us on WhatsApp, this is the link through which you can connect with us. So this is the link to connect with us on WhatsApp. Okay. So that's all for this week then. And thank you very much for joining. Keep putting your queries throughout the week, and then we will meet you once again next weekend. So till then, have a good time. Thank you all for joining. Bye bye.